This has been a long time in coming. We're having this conversation after 21, 22 years thinking about this.
Your eyes are burning, and you smell it, if there's dead fish around. Your day goes from being high aspirations of catching lots of fish to, well, we're not going fishing today. There's nothing to catch. I don't have bait. Can't get through the red tide. Everything's dead.
Red tide is a nightmare. Red tide is a problem for fishermen. It's a problem for people with respiratory issues that live on the beach. It's a problem for people that go to the beach to get their Zen time. Just problematic.
The red tide, when it's bad, you just can't really get away from it.
I mean, and if the sea and the oceans are dead, what are we going to eat?
I've never been more excited about the possibility of discovery.
3.
I have 100% confidence that what we're going to produce from Pace will surpass all of our wildest dreams.
2.
This is going to change the world.
1.
First red tide I remember was back in the mid-'80s. Don't remember much before that being all that bad, but in the 80s that I was driving the test boats at the Mercury facility, and I was in a little slow boat, and the dead fish of all species were floating on top of the water, and that was one of the first ones and one of the worst ones I can remember. I remember just people complaining on the beach. No, it's a bad deal. What we normally do is we run offshore and catch grouper and snapper on a private boat that I run. Clients would arrive between 7 and 8 o'clock. We run offshore, we fish all day. Try to get back at the dock by 4 because we aspire to have an outstanding catch every day, which means spending time at the fish cleaning table. So you get home exhausted, you're tired. It's a 12-hour day no matter what. I mean, it's a lot of work, but it's very rewarding. Well, it's my life, and it's everything. And we live in Florida. People come here to go on the water, catch fish, and enjoy the beaches. And that's not happening when there's red tide and death all over the beach. We're lucky right now we don't have the red tide, but it runs people up. I would like to think we could prevent red tide from happening, but that's almost like trying to keep cancer from happening. It's a tough one. You never know where it's going to pop up. I hope and pray that we can do something to turn us around one day, because it's terrible. Absolutely terrible. And hopefully NASA can get something going there.
The red tide can be so intense right along the beach that really no one is on the beach. That's further magnified if the red tide has also caused low oxygen levels and caused fish kills. And so when you have 80-pound, 120-pound grouper or manatee dead on the beach, rotting, you now have biomass, you have rotting animals, and that ammonia smell of rotting animals and rotting mammals and fish on the beach. The combination can truly make the beach just not tolerable for anyone.
Since I've worked here, we had a period of about 18 months where red tide was on and off nonstop. It pretty much shut down the island. We had a large influx of patients. It was pretty much a daily occurrence, somebody calling with a respiratory problem. We have a hard time telling people to limit your exposure. So it isolated a lot of people at that time.
I think that the more data we have and the more science and the more funding we can direct towards science to better understand red tide, and the more likely we are to be able to mitigate and take steps to at least make some measurement of improvement in controlling, predicting when it's going to be bad, but also controlling just how bad it is, and lessening the suffering not only of us, but also of our marine friends.
So you have to elevate your senses all the way into space. So only from a satellite point of view do you get this beautiful synoptic picture of our home planet. And if you weren't able to do that, there would be so many parts of the role of phytoplankton that just would otherwise be invisible. Most people don't realize this, but NASA plays a foundational role in the entire international study of Earth science. So I knew that I wanted to be involved in marine science since 8th grade. And I was lucky enough at the time, the public school that I attended in Central Connecticut had a program that brought me to the biological station for research in Bermuda. And that was a transformative moment. And it's not just learning how the satellite system relates to the oceanography I was already interested in, but I mean, good grief, I mean, the greatest collection of Earth scientists in the country reside here. Well, all right, so the ocean provides, right? It provides a food source. It helps regulate weather and climate. There are compounds from the ocean that make medicines and jobs, economy. All of that ties back to what is in the ocean. And so from a phytoplankton point of view, you have the beneficial ones that feed fisheries, the beneficial ones that are moving carbon around and influencing climate. There are also the harmful ones. Some of these are harmful enough that these phytoplankton could kill you. And they're the ones that form red tides, where you're seeing beach closures or oyster farms suddenly having to be closed because of contamination. They carry this particular chemical that tends to be an irritant to humans and animals or create an odor and so forth. It's not enough just to say, I see phytoplankton there. You know, if you're sitting on the West Florida shelf, for example, and you see a bloom of phytoplankton from space, it's important to know whether it's a red tide that might have some severe impact to that coastal community versus it just happens to be a lot of phytoplankton there. Some of these form in places like the Great Lakes, and there was an instance not long ago where a cyanotoxin bloom shuts down the water intake to the city of Toledo. And this is happening on more diverse areas, places where they weren't happening before. Sometimes they're happening with more frequency. Anyway, the point is that we want to monitor them. And that's where PACE comes in. We have been doing ocean color from space and atmospheric work from space for over 40 years. And we have this beautiful fleet at NASA and with our international partners that really have formed the foundation for what PACE Observatory is going to be. And they're wonderful at doing their job, which was, or is, to separate a signal from phytoplankton from everything else in the water column. But what they don't do well is tell you what is contributing to that biomass, what community is actually there. And that's because they use ocean color, but they're only looking at 7 or 8 colors of the rainbow. And they do that by having measurements of several blue bands, several green bands, and several red bands. But that's still 8 crayons in your box. If you wanted to actually see the subtleties in different greens and different blues, you need more color. PACE is full spectrum, full rainbow from the ultraviolet to the near infrared. So you would imagine this as being handed a box of 200 crayons. And if I asked you to paint, color the most spectacular landscape you could, which box are you going to choose? You want all the color. You don't want some of the colors. So the information content for any singular instrument on PACE is way more than we're used to. This is such a cool problem to have. So suddenly, the tools you have at your fingertips will fill in all the gaps of color that we could possibly want. We know the atmosphere is changing. Every time a pattern in agriculture changes, is there something that's altering nutrient availability to your local marine ecosystem that is suddenly changing how things are growing? You may be noticing in your backyard, if you have a small body of water, why are these scums of algae forming that weren't there a few years ago, and then they disappear and the timings are changing? We know carbon dioxide levels have increased over the past 200 years. We know that it has warmed our atmosphere. Our warming atmosphere, the physics behind it, are starting to change how our oceans behave. Circulation patterns are changing. Places are warmer than they used to be. Currents are evolving to bring nutrients to places they once were not. In many ways, you wish you would have had these eyes in the sky forever because, that information is so powerful. So there's a lot of benefit from an instrument like OCI where you can reveal phytoplankton features and algae features that you just can't see with the instruments that we have in orbit now. It is going to provide really a quantum leap in the knowledge base that we have. It's going to change our foundational knowledge of things, and we are going to stumble into new discoveries that, I can't predict. The economy is tied to it, not just coastal economies, but it's easy to think of it in a coastal way, that there are fishermen, there are shell fishermen, there's recreation associated with this. So if you enjoy eating, or you enjoy going to the beach or being out on the water, phytoplankton play a big role in your life, whether you know it or not. So the scientific community, which is inclusive of partners like NOAA, the U.S. Environmental Protection Agency, and other organizations like that do watershed management or have some responsibility for safe and clean drinking water, they spend a lot of time thinking about the frequency, the duration, and the extent of these harmful algal blooms. And I'm involved in a project actually that's really fascinating about using satellite data as a tool to start looking at longer term time series of these. So I don't know that anybody was specifically predicting a boom or bust of them over time, but they certainly are important enough, and resources to monitor them are scarce enough that using satellite information to start studying harmful algal blooms has been really, really popular and becoming more of the forefront of that field, at least from a management point of view over the past 10 years or so. And so the real origin of the PACE mission is circa 1999-2000, where Seawolves was flying and successful. Modus Terra had just launched. And at that point, the Ocean Color community had a whole new playbook for their research. And those missions were so successful the scientific community really started diving into, well, if we had to do this again, what happens now and what does that look like? And that evolved into a series of studies conducted at Goddard and elsewhere with collaborators from all over the country. And the genesis of the idea became a little bit more real. It would be so profound to have a new ability to look at this blue marble. You know, we're all citizens of Earth. Why don't we want to be watching it every day from space? Now we are 10.5 hours from launch. The deeper dive we take into the relationships between land, ocean, and atmosphere, the more we realize we don't know and we need to learn. It's going to revolutionize and allow us to take this huge volume of information that we've never had before and actually dissect it and interrogate it in really, really interesting ways. And we're going to start learning causes and effects, or just interactions and how different parts of the ecosystem start piecing together. So I can say without hesitation that the new data coming out of PACE from all three of its instruments is going to absolutely change the way we view our home planet. And what will come with that is a deeper understanding of how all the systems connect, why things are happening, why decisions we might make could influence other things downstream in the grand sense of how everything fits together.
My 10,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Booster ignition. Full power engines and liftoff of the Falcon 9 and PACE. $7 billion of thrust.
Come on, girl.
Telemetry nominal.
Steep climb into its
The vehicle continues to perform nominally. All 9 engines fire.
View from the rocket camera.
Engine chill, unstarted. Head back, engine chill.
Looking inside, there go the fairings. This will be the 12th. There will only be one stage to burn. And it's separate, known as SECO 1.